right. First get this to loop. Gotta get this new streaming stuff set up. Not now. All right. Chat and that. All right. Okay. Looks like things should be working. Hopefully my microphone audio's all right. Background music's playing. You can see my screen. That's good. That's good. All right. All right. Let's just kind of wait for a little bit for some people to join. What are we going to cover today? Okay. Implement control surface animations and add debug visuals. Okay. I think that's probably, and then we'll also maybe show roadmap plan. And now we'll talk about project. Yeah, there we go. That'll be our goals for today's stream. All right, one viewer. What's up, dude? All right, just waiting for maybe a few more people to join, but if no one joins in the next 2-3 minutes or so, we'll just get into it. Yeah. Yep. It's been a little bit since I've live streamed. It's I've gotten very comfortable during break. But yeah, still on break. Still on break. For now. You know what? Actually, no, we will just show the Trello board. What the hell? All right. So this is sort of the roadmap for the project. To kind of explain what the project is, it's a web game. It's a web game. For some context, I've played my fair share of web video games, specifically like Krunker.io, Shell Shockers, Wings.io. I think that was one of them. These are all just going off of memory, but basically, web games are surprisingly fun, and the barrier to entry is very low. So you can make a web game much more quickly than like a full Steam release for something. Also, I have a lot of friends who don't have good hardware. And when I mean bad hardware, I mean bad hardware. Like, I have friends who the whole reason we played these web games was because it was the only thing they could run. So my goal is to make a web game that I can play. If it goes well, I mean, it'll be live, so all of you can try it. But what is the game? The game is supposed to be a fighter jet dogfighting game. Okay? So if you've ever played War Thunder, those kind of controls in the browser, and in the beginning, it's just going to be 1v1. So, you know, the game like 1v1.lol, it's another web game. The whole point of that game is Fortnite 1v1s in the browser. Like, they mimic the controls of Fortnite. So I want that, but for dogfights initially. But as you can see here, I would hope to have like 16 player lobbies. So just a game you load into, 16 people flying around, all kinds of fun stuff. To show kind of where we're at with that project so far, I'll show you. I'll just make sure we have everything built. So I'm using C++, OpenGLES, and WebAssembly. I'm also building this for desktop though. So if this does get completed and launched, I would like in a perfect world to have a desktop version as well that has much better graphical features. So I wouldn't be using OpenGLES. Right now it is using OpenGLES, but I would ideally migrate to like a modern version of OpenGL. And then, yeah, you'd have a desktop version that you could play with more like higher fidelity and all of that. But fundamentally, you're playing the same game. And then there would be a browser version with lower graphical settings, but it's a browser game. So yeah, I'll show you. So far, the web and the non-web version are the exact same. So I'll play the desktop. This is now it doesn't look like much. This jet, I modeled this in Blender really quickly, but it is fully rigged. And this is kind of a demo of my, yeah, the flaps are kind of busted right now, but, and that's a code issue. I'll show you, the actual, like, rotation of the flaps, it works. So I can rotate local, we'll say 1.0, and then negative 1.0. And this will just be key pressed, and then we'll remove this. All right, so this will just rotate the flaps like slowly. But long story short, I have a very basic animation system set up. So like I can load GLTF models with, like, look at the flap. Flap is getting, maybe we stop rotating the whole plane, but you can see that the flap is actively being rotated. Although it would seem that the normals are not being rotated properly. That's really, we can fix that like really quickly. Normal rotation matrix, extract rotation, transforms a bone ID. Huh. Maybe we can't fix that right now. Well, let's see. Is this really that busted? Yeah, nope, the normals are being rotated. Maybe just not properly. No. They look like they are being rotated. Anyway, that's kind of where we're at. Right now, the plane rotates when I press A and D. And the goals for today's stream are pretty basic. Right now, what I would like to get done is let me just pull it back up. So we just talked about the project. I'd like to implement some control surface animation. So what I want is when I press back, I want the tails to flip. Rolling, I want the flaps to rotate, and then I'll have some rudder controls as well. The goal here, and by the way, the controls, because this is a browser game and there's not going to be like a lot of physicalized objects in this, it's pretty much just going to be the planes. I'm really trying to avoid using an actual physics system or like an external physics library, just because I would like to implement this in a way that's network friendly. Physics are not fun to replicate, especially when you're writing the networking from scratch. So I would like to write this in a way that feels like the planes are flying according to physics, but they really it's just basic, like it's all in this plane update loop. I'd like everything there. So yeah. And then if we get through that, I'd maybe like to work on adding some debug visuals, because right now the engine doesn't have any way to like debug arrows or collision shapes or anything like that. So we might get to that. This stream should go until like 2:15. It'll be longer than some of the previous ones I've done. But yeah, okay, so let's get to it. So first off the bat, I don't think I need to be actually rotating the plane at all when I do these debug animations. Let's see. Yeah, fundamentally, I would just like, when I press D, the flaps, okay. So, first thing, the way that the animation system works, because we're using a .gltf, we're using quaternions to handle the bone rotations. Quaternions, they suck. I mean, they're great, but they're not intuitive at all. At least for me. Some of y'all might think that they're really easy to work with. I definitely struggle. So we have this rotate local method. And what this does is it rotates, but it doesn't, like, you can't set your rotation to 45 degrees and then just have it stay there. So we have a couple options. This rotate local does work with like just local bone rotation. So one thing I would like to maybe try is the problem. This is key just press method also does not work properly. So it should like go for 1 frame, but it doesn't. See that? That's way too much. Yeah, that's way too much. It should just be 1 frame. So maybe that's the first thing to fix, because that's kind of something. That's something we need to fix. The way that works, we've got our mouse, our key. our previous frame key states and our mouse key states. Although actually, now that I'm thinking about it, maybe that's the issue. So right now, the way that the key states are updated is every time we get a new key press, like GLFW key press callback, first we check to see if the key is like one we handle. And then we update all the key states. Like the last key is set to this. The problem is this is entirely dependent on the key callback and not on like, we're not updating it every frame necessarily. So that makes sense why this is happening. However, I do have a reset state method. This is just called in the main loop at the very end. We honestly should probably be moving this here. Last key. This is not the most optimized way to do this, but we will do it this way. Was it GLFW max keys? Yeah. GLFW max keys, I plus plus. And then for all of these keys, we are just gonna set their state. And then we'll do the exact same thing for the mouse buttons. GLFW max mouse buttons, last mouse button states, mouse button states. All right. Does that work? That looks like it works. Okay. So now we actually can maybe work with this properly. All right. So I would like to rotate this. Another thing that I'm actually pretty proud of. All aircrafts are, I'm trying to have like a data-driven design kind of thing here. I don't want to write everything in code and have to recompile the engine every single time I add a jet. And I also would not like there to be like a specific class for every kind of jet. I'd like there to just be a master aircraft class that loads all of the necessary data and functionality from files. So for example, this is the demo jet file, and here's all of the settings. And this is all mapped directly to like all of these structs that are housed within the aircraft class. So basically, yeah, everything's handled within an external file, which does open the door to things like hot reloading if I ever really need that. So let's see. Resource dot what? I don't have autocomplete set up in this IDE just yet. What was it? Resource settings flaps max angle. That's what it was. All right. Rotate local resource dot settings dot flaps max angle, and then we release else if input manager is key just released w key a. Then we don't need that. We can go here, boom, and then this should just rotate it back. And if we did this right, hey, what's up? I'm gonna try to pronounce that username. What's up, Kuzi Geet Ister 7? Yeah, I give up. Oh, look at that. That works. Okay. Now, the other thing is that the flaps. Let's see. The other flap, wing R and R. I think they actually are like opposite orientations. Wish you could zoom in on the code a little more. Yeah, absolutely. Thanks for letting me know. All right. Is that better? It's actually really easy for me to read right now because of this. All right, there. That should be better. Yeah, I'm Turkish. Don't even try, lol. Well, thanks for being honest. All right, let's see. Yeah, okay, so the flaps seem to be working a little better now. Okay, and then we'll have the same logic for key D. Only we'll flip everything. Yeah, thanks. All right, let's see. This should work. We should now have, look at that. Flaps now rotate. And because this is all handled in a, now I'd like this to all be lerped. What ID am I using? I'm using Zed. I recently switched to Zed from, I wouldn't say switched. I still like love the JetBrains tools, but my lightweight IDE, I'd like to have like one IDE that I use for all the languages. Zed, written in Rust, very fast. I'm not cracked enough to use like Emacs or why is the name escaping me? There's Emacs, Vim, NeoVim, any of those. I'm not quite at that level. So yeah, right now using Zed. Love it so far, but it's very early. Like there's not a ton of plugins for it yet, but I plan to be one of the early adopters. Okay, that works. Now let's add functionality for the flaps. The flaps will be W. This will be down. Tail. I think it's tail L. Yeah, it's tail L. Tail R. I think these actually rotate the same, but their orientation is a little different. I played around with these settings a little bit while I was loading in the skeleton. I have to say, loading in skeletons from a GLTF file, first time ever trying to do it, and man, that was a challenge. Okay, let's see if this works. If I get this off the bat, that'd be kind of cool. Okay. Not quite. Oh my, what the? Oh. That's too bad. Although, I think if we do that, that should sort everything out. Let's see. Yep, there's that. Okay, and then we'll just have... should probably group these together, honestly. For flaps, animations, and then we'll just move this here, testing for tail and animations. Also, let me know if you can hear the background music. I can't. I have not. Like, I can't. I have it playing some sort of like ambient audio in the background, but you know, I myself can't hear it at all. But yeah. Yeah. All right. Let's see. Take this here. Is key just pressed? This would be S. And then we'll just flip all the settings. This seems to work so far. Although obviously none of this will be done through like input. All of this, these flaps and rotations will all have to be done through like the plane's motion. Okay. That's better. That's some aggressive flap movement, but sorry, tail movement. And then this plane, the way I designed it, there's no rudder. The rudder and the flaps are both handled by the same thing. That's going to be a little tricky. Although, I think the rudder... Ah, we're going to need a... Oh, we're going to have to add rudders. Okay. Rudder.r.l. And for this, we'll literally just have it be the tail. Rudder.r 3, and then we'll go and add that to here. Tail L. Hint. Do you have any useful TM C++ TM tests for beginners? C++. I'm not sure what the TMs are. That might... Is that... Did you type emojis or something? I'll just read that normally. Do you have any useful C++ tips for beginners? Maybe like... I don't know. I came from Java. So actually, you know what? One thing, if you're coming from a language like Java, Python, or C#, this might just be like me being slow to pick up on things, but I never learned the difference between pass by value and pass by reference. In my mind, I just kind of wrote code until it worked. But I never really knew like that I was copying a value and then it was getting used in the function and not actually modifying the original value. Of course, there are ways you can use pass by reference in like Python, in Java, I believe. But any libraries I used that had that functionality, I just kind of had to play around with how I was passing parameters until I actually like figured it out. But having an actual understanding of like the basics of that. Also pointers, kind of nothing to explain there. I mean, pointers are pretty crucial now. Yeah, it's just an inside joke where I would put copyright in my end of every word. I get that. But yeah, I would definitely say like make an effort to understand the basics. That sounds really like, you know, like a no-brainer, but coming from someone who just jumped right in, like I learned through projects, which is great for like quickly learning something, but at the same time, it makes it very easy to miss out on some very like important language features that you just happen to never have to use. Rudder, and then rudder. Yeah. All right. And because the rudder and the tail are the same in this plane, it might be... I might have to revisit this code. I will have to revisit this code. Moving forward. Let's see. For rudder animations. The rudder... Actually, I think the... I feel like our keybind should be different. If, like, for rotating the tail, it should be Q, and then E. And then for down here, this should be A, D, and then we'll have to do rudder R, L, R, rudder L. You know I'm not cracked enough developer to be using Emacs when I'm still using my mouse. What will the game look like? Is it a flight simulator or something? I did use Nolman's JSON library. And yes, it is Zed. And the game is supposed to be... Have any of you ever played Krunker.io, Shell Shockers, Wings.io, or Airmash.io? Or 1v1.lol. All of these are browser games. I played them growing up. I played them with a lot of my friends who didn't have good hardware. And this game is supposed to be... Picture, at least initially, it's just going to be 1v1 combat. And then I plan to have like 16-player lobbies. But the goal is War Thunder-based aircraft controls in the browser combat. Does that make sense? So like you'd be able to send like a lobby invite to your friend, maybe like a code or something, press play, you'll both spawn on opposite sides of the map, and it'll just be a dogfight. You'll have guns, radar missiles, heat-seeking missiles, and like but there'll be a basic like terrain system, so that you're in like a map. Maybe like a basic water, like ocean stuff. Ideally, I'd like to have volumetric clouds. I know that's a lot to ask, but I think OpenGLES has enough shader features to where I could implement like Raymarsh volumetric clouds. Worst case, that only exists in the desktop version. There is a desktop version and a web version of this. Right now, they're the same. I'm just like compiling them differently. I'll show you the web version. But that's essentially the goal. I would like this to be not War Thunder in the browser. That would be dramatically overscale. That's the desktop version. The web version, it's the same. All the same. Right now, the keybinds are a little messed up. But yeah, cool. I would play that. That's awesome to hear. Listen, as soon as here's my goal. I would like there to be a demo where you can fly the plane around in just an empty map. Maybe it's like a testing environment, maybe not even an actual map. I would like that to be live as soon as possible. So I would like there to be just like something people can play and get feedback on the controls. While that's happening, ideally while y'all are playing that, maybe I'll be going in and adding like the map stuff. So skybox, terrain, water, clouds. I really want clouds in the browser. I want to prove that it can be done. I don't even think that's a big thing to prove. I'm using OpenGLES, not WebGPU. If I was using WebGPU, dude, the graphics could be like incredible. The reason I'm not using it is deliberate for two reasons. One, I like OpenGL and I know I can develop quickly. And with school starting up, I don't know if I will have time to actually learn a whole new graphics API. But I also want to force myself to have hardware constraints. OpenGLES is very limited compared to OpenGL. I think it would be a fun challenge. Are you going to hire playtesters? Y'all will be the playtesters, hopefully. I mean, I probably wouldn't hire any playtesters. I would just host this. And then anyone could join and play. And maybe there'd be actually like, now that I'm thinking about it, maybe there'd be a way in the game to report feedback. Like maybe there'd be a little button you could click, little text box, send feedback. But yeah, I want you guys to be able to play this as soon as possible. I want to be careful with any promises I make. I have no idea. Last semester, ROTC and school floored me. I mean, the project that I got done, if any of you saw previously, I made this um, like foliage rendering system demo. That took like 2 months to make. If I was making it at home, like without school, I probably could have done that in like 3 weeks. School made it unbelievably difficult to get any actual software work done. So I don't want to promise anything. I have no idea what next semester is going to look like. But I'm done with calculus. But I have statistics. I hear statistics is something people either love or hate. I loved calculus. I thought calculus was easy. Calc 1, 2, and 3. But that may come back to bite me with statistics. Maybe my brain just works differently in that regard. I don't know. I feel like that's kind of doomsday thinking, though. Although, I completely messed up the keybinds. Okay, for flaps, that would be Q, Q, E, E. Tail animations, W, W, S, S. And then rudder. All right, let's see. This should, we'll see how this goes. What do you use to compile for web? I use Emscripten. I can show you like the CMake for this. Okay, so that's, so far that's pretty good. Although I think in this case, we're gonna go remove this, add this, remove this. And this should make it where the rudder, yeah, that's correct. Although the rudder has its own independent rotation, so we need that within the settings. Max rudder angle, tail max. Let's set it's like 30. I feel like we're gonna want less. And then we'll just use rudder max angle. All right. All right, that looks, yeah, and you can see the, yeah, this is W, S. Is that backwards? That's backwards. Gosh darn it. Those flaps are backwards. Let's see. W, S. Honestly, I'm lazy. Just for legibility, we're going to flip these. Oh my gosh. All right. And then we're going to just W, W, S, S. And then this should have them working properly. But yeah, I'll show you the Emscripten setup. So I have a CMake file. Emscripten's really nice. It has all of the compilation features you need to write like conditional compilation. So like really, if I just have this if Emscripten statement, anything in here gets run if I'm compiling for the web, and then else anything in here gets run if I'm compiling for desktop. And then anything outside just gets run for both. There's probably some stuff that I could use for both, actually, now that I'm thinking about it. I don't need this tween library just yet. Yesterday I added a tween library, but I actually should probably remove that. I did check GitHub. Good. Let's see. I probably should move this. And if it ain't broken, I'll fix it. But where you can actually see the differences in the code is, for example, the main loop. You know, if we're compiling for Emscripten, we have a way to get the canvas size. That lets me, actually, I'll show you what that looks like in action. I can actually resize the canvas, and it works the exact same as if I resize the, oh, I see. Tween dummy needs to be removed. All right, and then Lemon Web Dogfight. Oh, you checked the GitHub. I see what you mean. Yeah, it is on GitHub. There's no documentation for it yet. I started this project probably 2 weeks ago. It took a while to get skeleton animations loading. And the way I'm doing it, I actually would like to redo in the future. It's not the best. But as you can see, if I resize the browser, like the actual canvas in the browser, the camera works properly. And that's entirely because I have, you know, a way to run like JavaScript essentially here. And then like little things, if we're using Emscripten, we'll get the browser window scale. And if we're not using Emscripten, We'll just use our own window size. The GitHub page title is Web Dogfight, but I'm toying with the idea of calling this like fox2.io. The reason for that is when fighter jets fire heat-seeking missiles, they say Fox2. It just means, launching a heat-seeking missile, and it sounds cool. So, fox2.io. Believe it or not, this isn't my first attempt at making this game. I had this idea for this game probably 2 years ago, and I worked on it in Godot. And I don't know. I don't like working with Godot. That might be a hot take, but every time I pick up Godot, my project gets doomed. At this point, I just know that if I work on a project in Godot, it's not going to get finished. It's just not as enjoyable to me. I like making engines. Well, at least doing everything from scratch. So yeah, we've got some basic flap controls. That's really cool, actually. That worked really well. Okay. Obviously in the future, this will have to be done through rotation. Actually, I think I know what we'll do next. I think I know exactly what we'll do next. Okay, so now we're going to handle everything in rotations. And just so you know, before this pops up again, this code right here is pretty obviously generated by Claude. I think this is an important moment to talk about where AI comes in to like coding, because I have some thoughts on this. AI should be deliberately avoided when you're writing code, especially like C++ and Rust and low-level languages. It should not be a last resort, like this is too hard, I'm going to use AI. If it's too hard to debug, suck it up, debug it. We all had to do it before AI. The only time that I would say AI is worth using is when you have stuff like this rotate around point function. Could I have written this myself? Yes. Do I know everything I need to know to write this myself? Yes. Would it have taken me a frustrating amount of time to sit there and just like think it through? Yes, also yes. And I needed camera rotations done quickly. The goal of this project wasn't to learn how to do camera rotations. So I generated this with AI. Another important area you'll see AI being used. I had a demo cube at some point, and I used AI to generate the vertices and indices for that cube. Nobody is going to say, oh, generate a set of cube vertices in your head on the fly. I guarantee you if AI didn't exist, I would have gotten this from the Learn OpenGL demo page. 100%. So that's my spiel on AI. I even wrote important. These vertices were generated by Claude. I don't want people to think I wrote this because I don't want to take credit for code I didn't write, but that's my thoughts on AI. I think it's a very big way to like shoot yourself in the foot when it comes to action, in terms of learning stuff. And by the way, I'm not perfect with this stuff at all. I mean, I very much there have been times when like I've caught myself using AI with something that I probably should have done myself, but really try to make a conscious effort to avoid it. Yes, you can be a faster developer, 100%, but you'll be a faster developer who doesn't actually know what they're writing. And before you know it, your code base will consist of a lot of stuff, an uncomfortable amount of code that you don't know how it works. That's when you know you're really in trouble. Like when you look at your own code base and you have to like think, what is happening here? Because you didn't write it, that's a huge red flag. You should probably rewrite the code that you don't understand. But yeah, sorry, that was not off topic, but definitely long-winded. I'll make this bigger so y'all can see it. But yeah, fox2.io. Let me know what y'all think of the title. I think it might be fun. I think the next thing to do now is to make these animations work based on rotation. And the way I'm going to do this... Okay, so here's have you tried Vulkan? Okay, I have tried Vulkan. I did the Vulkan triangle. I did basic Vulkan right before school started. I said that in the summer I was going to become a Vulkan developer. And quickly I realized I simply did not have the time to devote to it. At least not yet. I'm not someone who could learn Vulkan in a week. It would take me a little bit more time. And until I have that time what I mean is I sat down and wrote the Vulkan triangle probably with like 2 weeks left before school started. Big mistake. Big mistake. And I realized that this whole next semester would be, like, I knew I wanted to do a project. I don't want that project to be making a cube in Vulkan. and spending what little time I have to program doing that. How old am I? I'm 20, which is so odd to say. Yeah, I'm a 20. I'm a sophomore in college. Yeah. Let's see. It takes a lot of time. It does. I honestly am going to learn. Here's my plan. I'm going to learn WebGPU before I learn Vulkan. I think WebGPU, and by the way, I actually have done some WebGPU. I would not be starting from scratch with that. But WebGPU is a good intermediary. I can tell you it's a good intermediary because one thing you don't have to worry about with OpenGL, you don't have to worry about device management. You don't have to worry about semaphores, synchronizing CPU and GPU stuff. You don't have to worry about really anything in terms of that. Yes, that makes for faster development, but it also, I mean, the modern graphics API, you have to know how to do that stuff. That's just part of the deal. I wish it wasn't that way. I look forward to a future where Vulkan somehow lets you do more, makes you worry about that less. I also don't like pipelines. I love how in in OpenGL, you bind shaders on the fly, you bind buffers on the fly. You don't have to compile a pipeline beforehand that is immutable. Vulkan, that's the case. You have to say, I will use this vertex shader, this fragment shader, and these models will be using that before you run anything. You can't do that on the fly. Vulkan is going back on that a little bit. Like now there is, I believe it's called dynamic rendering. You could correct me on that, but I believe it's called dynamic pipeline state, dynamic something. And it's basically Vulkan trying to go back and allow for more mutable pipeline state. But I don't like that. I really don't like that. And WebGPU does have that, but it's not nearly as much of a pain to work with as it is in Vulkan. Vulkan is really just like, you gotta love the game, man. You gotta really be into writing all of that boilerplate. And the thing for me is, I mean, I get tired when I make a new OpenGL project. I don't like the fact that I'm gonna have to rewrite the same window managing code, the same frame buffer managing code. Really a lot of code that I've written like multiple times before every time I start a new project. I like pipelines. It makes you think ahead. Yes, it does. And if you like pipelines, that's really actually good on you. You're in a better situation than I am if you like using pipelines. I don't. I like doing things on the fly. Yes, that promotes some bad practice, but it also is just much faster to develop. And I very much feel like I'm short on time. So if I can do something quickly, I really like getting that done. I don't like spending weeks on debugging something or boilerplate code. I'll do it if I have to, but yeah. If I really am serious about this, if I'm really being honest with myself, I really do need to learn DirectX 12 and or Vulkan if I really want to get hired for this. That's kind of a must, and I know that's a must. But I also, WebGPU is supposedly gonna play a bigger role in the future. I think it might be something to look into. I'm also trying to learn Rust at some point. C++ dominates the industry. I would like to learn Rust. I think there's a huge amount of potential with that. And WebGPU and Rust go hand in hand, not just for the browser, but also for desktop. Rust has WGPU, the Firefox, WebGPU, not Rust bindings. Someone corrected me on the most recent video and they were right. The word escapes me, but it's not a binding. I think that would be what I'd like to do before I dive down the Vulkan and DirectX 12 rabbit hole. But it'll have to happen. Okay. Sorry, I have yapped for so long. But okay, so the first thing I think I want to do is I want to rotate the plane now. All of this stuff. Yeah, this is for rudder. So let's just rotate the plane. Transform.rotation.y plus equals, for testing purposes, we'll say 25. Minus equals 25. Minus equals 25. Plus equals 25. And then ideally, this will rotate the plane. What's good, G? Just subbed. Good luck with your game, man. Thank you, bro. Much appreciated. I think that works. Want to make sure that nothing getting totally scripted. Yeah, that works. Now let's lerp it. So here's what I'm going to do. I think I'm going to have a separate transform. And this transform is going to be, well, we don't want to lerp the position. So we'll just have a vector 3 of like target rotation. And then at the very end of everything, we're going to try to lerp to the target rotation. So we'll say transform.rotation.y equals lerp. Actually, we can just lerp the rotation. Math utils.lerp glm vec3, and we'll lerp transform.rotation to target rotation, and we'll do it using time delta time. All right, and then in here we should just be able to say target rotation dot y, and we'll just copy. This is, I hate how much I have to copy. Control C, Control V, my friend. Control C, Control V. All right. G3. WebGPU is good. It's cross-platform out of the box. I did work with Metal, and I hated myself. And I wouldn't have to deal with that if WebGPU becomes a good standard. It's true. It's true. I hope WebGPU really does play a big role. I think that would be so cool. I think my hot take with graphics programming, browser games having better graphical capabilities and having more, like, there's so much potential with browser games, and the barrier to entry is so low. Steam, you release a game, you're competing with everybody. What AAA browser games are there? They don't exist. The best browser games are indie games, and the worst ones that, and by the way, really bad browser games, that there are browser games that get tons of players that if they were released on Steam would flop instantly. The barrier to entry is much lower. Now, if we did get WebGPU playing a big role, that might be, that might change things, but I like that. I hope that happens. Can you use WebGPU outside of? Yes, you can. Yes, you can. You can use WebGPU for desktop. You can use C++. I believe there's a WebGPU binding for most languages. I think you can use like C#. I tried WebGPU with, I'm dumb. I tried WebGPU with C++. I used Dawn, which is Google's C++, but what? We're gonna ignore that. That didn't happen. Transform that rotation. So somewhere in my lerp code, you know what? I'm just gonna make sure we're doing everything here correctly, and we'll just do float. Let's see. Please don't break. Okay, there we go. But yeah, you can use WebGPU outside of the times 10. You can use WebGPU for desktop and the browser. Dawn was hard to link. It was. It was. I spent a lot of time. When did I? Yeah, I used. Yeah, very true. The rudders are backwards. I did use Mozilla. Yeah, it's definitely the C++. I mean, if any of y'all watch my videos, I did a video recently and I talked about how the C++ bindings for WebGPU were definitely very, very premature. What on earth? I don't know what happened there. I don't know why the plane is spazzing out occasionally. Okay, now the next thing I want is let's see. I want this rudder to lerp according to the rotation. You'll see what I mean. That rotates that. We're going to do this all in a private method, by the way. This should definitely just be, let's see, void, apply, control, surface. There we go. Okay, we'll have our void aircraft apply control surfaces. All right, and then in here, I think what we're gonna do, so we'll basically take the difference between the aircraft's rotation and its target rotation, and that will affect how the rudder works. Let's see. Okay, we'll copy this. I'll say rotate local. Wait a minute. The way we're doing this is going to be difficult. because we're using, oh my gosh, because of this, the fact that we're rotating it local. That's going to be frustrating. Okay, so let me think. This is where we have to use some logic here. There's got to be some sort of multiplier we can have here. So I would say if, okay, we're rotating this by a certain amount. Maybe for now we don't worry about the lerping just yet. Maybe for now we are just going to copy all of this and we're going to only have the animation code in here. This is going to be for later. And then in the update, and then we'll go back here and we'll remove all of this. And then let's see, this is S, so that would be rotation.x. And then boom. At some point I'm going to have to handle like local rotations. That's something I'd like to have the debug drawing functionality for, just so that I don't have to do any of that in my head. I've tried before. It's frustrating. Q would be Z, and we'll have to change some of these pluses and minuses. I'm gonna have to toy around with some of these values. There, 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 there. Let's see what's correct so far. Oh, I'm not applying any of the flaps. Apply control surfaces. Okay. Draw, run. Okay. So this works. That doesn't, and that doesn't. Because we're not actually lerping any of these rotations here, are we? Yeah, we're not. Transform.y. This should probably be happening after all of this. And we will do this for each axis individually for now, until I can verify that that previous really weird bug we had doesn't happen. Also, it should be X, Y, Z. One of y'all asked a tip for C++. I'd say this just goes for every language. Always do X, Y, Z. Don't scramble up your coordinates. That works. Oh! I got it almost all correct on the first try. Let's see. We're gonna... That was actually very lucky. I'm very happy with how that went. Okay. So now we've got some basic aileron, control surfaces. We should also add a brake. I'm going to have like brakes. Look at that. This is some aggressive rudder. I think we should probably have that a little less. We'll do 15, 15, 15. These should be constants, by the way, for now. Rudder rotation 15. Sorry, this would be, what is it? Roll, pitch, yaw. This would be yaw. Roll, pitch, and these will be 25. Let's see. Yeah, this is yaw rotation. Boom, boom, boom. Always avoid magic numbers. Another really, really important thing. Oh, this shouldn't be here. I forgot to delete that. Q would be roll rotation. X would be pitch rotation. And this would be yaw rotation. All right, and we'll build that. I've gotten a lot more viewers than I really was expecting. Uh-oh. Did y'all see that for a second? I saw that. I don't know what. Uh-oh. That's not good. Okay, I really need to figure out what the heck is going on with that. Oh, wait, did I delete something important? I think I did. Oh, I'm stupid. I'm stupid. I'm so sorry about that. Yeah, Q, roll rotation. Gosh darn it. And then W, pitch rotation. And then this, yaw rotation. I use the mouse too much. I know. I will one day. Never. I'll throw away my mouse one day. One day I'll be such an insanely cracked developer that I won't need a mouse for anything, ever. Although, that may not be today, because for some reason that's happening. Well, why is roll breaking? Let's see. Apply control surfaces. Apply control surfaces. That's not it. Yaw rotation. Roll rotation. Q. C. Target rotation. And then we're lerping all of this stuff properly, right? What if I just said that it's equal to target rotation? Let's make sure. This is the ugly side of software. There's so much just bogus poking around into. What was that? Like, I don't. Oh, it's backwards. Okay, so that's definitely the Y issue. If we remove the Y rotation, I think that's what's causing problems. Because that, I mean, if you saw, that was rotating along the Y. Of course. Okay, that works. Or not. Yeah, that's definitely the issue. We'll just say target rotation.y for now. Until we know what the issue with that is, we'll have to... Okay. I do want to know why... Okay, that works so far. Although, okay, so if we're going up... See, all these rotations are happening in world space. That's a really big problem. Oh, I'm going to have to work with quaternions again, aren't I? That may happen off stream. I'm not going to kid you. I think I don't want to subject y'all to that. That would be cruel. You've all been too nice to go through that. Let's see. Yeah, okay. Ironically, that works. But sometimes it just doesn't. I guarantee you it's an issue with like the frame rate or the delta time variable. Like at some point, delta time is just freaking out and we're rotating a ton. But that actually looks pretty good right now. I'm actually really happy. And because this is all data driven, I can adjust all the rotations as needed. That's pretty cool. There's no movement just yet, although I did have some movement code here that I removed yesterday just because we're not ready for that yet. And then, okay. What time is it? 1:30. We have about 50 minutes. All right, let's get some debug drawing, okay? I like doing graphics more than I like doing anything else. Okay, so well, that's done. Add debug visuals. Okay. Now, the way I've structured this engine, I'm trying to do some best practice. Even though I'm only supporting OpenGL ES with this, I am writing this in a way to where in the future, hypothetically, I could switch the API out. Let's just say in a perfect world, Fox2.io becomes game of the year and everyone loves this amazing browser game that I developed, because who wouldn't? And we want a graphics overhaul. All of the API calls are happening within the graphics backend code here. There's no GL calls happening outside of this. And if there are any, it's like window resizing stuff, which can be totally fixed. But yeah, all of the GL calls are done in here. Now, right now I'm using, I've written this in a way to where it looks a lot like I'm using OpenGL. Like, I'm using OpenGL when in my main loop, let's see, scene.draw aircraft. Another important thing. I'm not using an entity component system. That's way too much for the scale of this game. The aircraft, in the future, the terrain, the water, all entities are responsible for drawing themselves. So the way I used to do engines, or the way I've previously done engines, I have a function that loops through all of the entities in the scene and then draws them, if that makes sense. So think of it this way. I have like a scene manager, or like a graphics manager, and there'd be like a function, graphics manager.draw scene, and then you'd pass in the scene. And then it would read everything in the scene and draw it. That quickly ran into a lot of limitations. One issue, when you do things that way, you have to, in the graphics manager, like if you want custom rendering functionality for all of the trees, in that manager, that rendering manager, you have to go in and say, okay, is this entity a tree? If it is a tree, I have all of this separate code I want to run on it. Quickly, that gets out of hand when you've got scenes with tons of objects that all have their own special drawing functionality. So the way I'm doing it now, the way I should have done it, all entities have to draw themselves. The aircraft has a draw function, and I have all of my drawing calls for the aircraft here. Right now, it's really easy. You know, we can upload shader uniforms. Think of it this way. If any of y'all have ever used Raylib, which is awesome, by the way, shout out to Raylib. Raylib has this thing that's like begin draw 3D and then end draw 3D. And then you like draw cube. That is how, and then you'd have your like cube parameters here. This is immediate mode. Like, you don't have to have any setup beforehand. With OpenGL, you have to go in and you have to say, like, you have to define what a cube is. Like, one time in the beginning, you have to say, okay, a cube has all of these vertices, generate all the proper buffers, generate all the shaders and everything. And then you can just draw the cube whenever you need it at runtime. But it's frustrating because you don't want to have to, every time you like debug drawing. This means now for every shape I want to be able to draw. So lines, cubes, planes, whatever, circles. I have to, like, in the beginning, set it up to where I have to define what these shapes are. And I'm probably going to do it that way this time. It's frustrating. But the way this backend is set up is I can just on the fly say begin draw mesh, pass in a mesh, a shader, a camera, and a transform. And then any extra features that I need, shader uniforms 9 times out of 10, I can pass inside of this, okay? That's really it. And actually this, because of that, would not go here. This would go after, okay? So that's what I want, how I want this to work. So first thing we should do is we should have all of our, I'll have it at the bottom, debug drawing. Static void begin draw what? Actually, we don't need begin draw. Okay, let me think. How do we want to do this? We would want like a draw cube. Do we want a draw cube method? Yeah, we just want a raw draw cube method. Draw cube. Now, that means we will have to have a very basic shader, another shader, debug.glsl. And then we'll copy all of the flat.glsl code because that really will be all we need here. I don't know. Yeah, extract rotation. Let's see. World rotation. Just making sure this all applies. We won't need any normals. Debug drawing will have 0 shading. I'm deciding that now. And it will have no textures. It will purely just have that. We don't need p normal. Yeah, we don't need that. Make sure we don't have any of that. Shadow color, sun color, we don't need any of that either. World position, rotation, just making sure everything works right now. Yeah, that looks about right. Okay, so we're gonna have a very simple shader in that regard. And then in the back end, I believe there is some initialize function that I have here. Let's see. Create cube. Yeah, that's separate. That's actually, that might have everything we need for, we're gonna have to have a static cube, aren't we? Okay, before I do this, I just want you to know, I know this isn't best practice, but to do it best practice would be more code than I'm willing to write for debug drawing, okay? Now, you don't want to have, from a security standpoint, you don't want to use static methods, static variables all the time. And I learned this in class, believe it or not. I'll be the first to say I don't usually learn a lot in class. Usually I do most of my learning on my own or in projects. This is one of the actually important things I learned in class. And it had nothing to do with the lecture, actually. I got the professor to go on kind of a side tangent, and that's where I learned this. Static methods, all of that stuff in an engine, in a program, you run the risk of, if I was a hacker, I like static variables, static methods, because their location in memory never changes. By definition, they're static. They are established at compile time. So when I compile my program, rather, I believe it might actually be pre-processing, not compile time. But basically, before I actually run my program, I have already established that this function is going to go at this memory address. This function is going to go at this memory address, and it will stay at that memory address until the program ends. What does that mean? As long as my program is running, none of the variables that are static or the methods that are static change, which hackers like, because if they know where something is in memory, that gives them leverage. If you want to write secure software, so like defensive coding practices, nothing should be static. Everything should be dynamic. You want the memory addresses associated with variables, functions. Think of it this way. In a perfect world, this graphics backend would be an object, maybe an immutable object, but an object that I pass around in the engine with references, with pointers, however I pass it around. And that way, I'm not establishing that this graphics backend will always stay at this one place in memory and it will never change. And that makes it harder for hackers because they might know where this variable is in memory at this time, but let the program run a little more, it may not be there anymore. So it's not the best practice to have a bunch of static methods. But I will say this, and I'm not trying to throw anybody under the bus. I've seen my fair share of people who have made successful games in C++ who have this kind of stuff in there. So if we really were freaking out about security, people would not be playing their games. And by the way, they recorded all of this on live stream. So I'm just telling you, it's not that deep. But if it was that deep, that's what I would do differently. And that's why Rust is super, that's one of the things that Rust has that's very nice. Everything's an object that must be passed around. It's very hard to do static stuff in Rust. You can, but it's hard. Rust kind of forces you to have a reference or like a mutable or immutable reference and pass it around, if that makes sense. All right. So graphics backend, we'll have a static mesh, and we will call this debug. We'll call it generic. Debug cube. Debug cube. And then what? Do we have some sort of like startup function for the engine? I think we do somewhere. Graphics backend resets. No, it's the loop. Primary window. Graphics backend. Set backface culling. We don't. That feels wrong. We need that. We should have some sort of backend initialization. Static void initialize. Actually, I think we have like a load resources function. That's what we need more than anything else. Do we do that? Scene manager, graphics backend, load resources. Okay, fine. We'll load resources. And then within that, we'll have our own void graphics backend load resources. And then for here, we'll say debug. Did I capitalize debug cube? I did. That's stupid of me. Equals load what? Create cube. That's all we have to do for now. And then in our draw debug cube, we'll have our method down here. Let's see, void graphics backend draw debug cube. And then for here, it should just be, we can use our own internal methods we have. So begin draw mesh. What do we pass in? Cube. Here we'll have a camera. We'll need a camera reference. And we'll need a transform reference. Hi, bro. Let's see, cube. And then we also need a debug shader. We're gonna have to load that internally. And we're gonna need another static shader. Static shader, debug shader. And then in our, and up here, we'll have to, what, debug shader equals create shader. I believe it's create, yeah, resource path. And then we'll have, what was it? Resources slash shaders slash debug.gsl. Okay, that should work. And then down here in our draw debug cube, which takes a camera and a transform. Okay. Here we will use our debug shader, camera, transform. And then it should just be as simple as end draw mesh. And I think that does take in a cube as well. And draw mesh, yeah. Cube. Debug cube. Not cube. All right. Now, please work on the first time. Did it work on the first time? And we linker error. Okay, what did we do wrong here? Undefined ref. Yeah, okay. It has to be inline. Let's see. Inline static shader. Yeah. By the way, for all of you who don't know, I'm just going to assume, I'd like to pretend that I'm teaching people, okay? For all of you who don't know, declaring things in header files does not actually allocate any memory to them. You have to... Another way you could have done what I just did is you could have gone and just declared graphics backend debug cube. I believe that would have worked as well. Let me just make sure. Because what that does is it tells the compiler, okay, allocate memory, not declared private. Maybe this isn't the, is it? Mesh. I think I'm missing something here. But this would be another way you could have done it. Yeah, there. So this line does here is it tells the compiler, okay, there's this graphics backend variable called debug cube, and you're simply saying allocate enough memory for a mesh. Now in the more, I believe it's C++ 17? I believe it's C++ 17. You can now do this thing that says inline. What inline does is exactly what I just did up here. It just does it in, you can write all your code in the header file. Inline static mesh. Didn't I just save that that's no longer there? Maybe I didn't. Yeah, there we go. Okay, that seems to work. Now, let's try our draw debug code. Draw graphics backend draw debug draw what? I forgot what the method name was. Draw debug cube. Yeah, that's what it was. Aircraft draw debug cube. We need a camera, which we already have a camera, and then we need a transform, which we will just make our own new transform dot position. Actually, I shouldn't do this. I shouldn't do this because we're going to make memory for we're going to allocate a different transform every single frame, which is not performant, but it's in the name of debugging. Transform t equals transform, and then we'll say t dot position equals transform dot position, and this will just make it where the cube is permanently on the aircraft. This should be correct. Why is that capitalized? Okay. Man, I'm getting more views on this stream than I expected. Very happy about it. Why is it invisible? Maybe it's inside? No, it's not inside. Where is this thing? Debug.glsl. We're not getting any issues. Attempting to create shite. Ooh. Is the shader not getting created? I only see that we're loading the skeletal. Oh, we're not calling graphics manager initialize. We should probably do that here. Load resources. All right, let's try that. Okay, let's see. That was not because of what I wrote just now. That's bug. That bug has been happening this whole stream, and I'm gonna fix that later. Also, the key. Oh, wait. Did you see that? I think I saw a cube. No, I'm crazy. I'm just crazy. There's no cube there. I wonder why. Ah! Shader error. Okay. Oh, what am I doing? We just want a red cube. I don't think these are floats anyway, but we'll worry about that later. Oh, no compile errors. No cube either. Okay, it's loading the right thing. Something feels off about that. That should be working. Maybe our scale is 0. Maybe that's what's going on. T.scale equals GLM vec3 1 point. Let's just try that. Let's set the scale to 1. Maybe it's bigger than our camera, which means no, it's not. Where on earth is the cube? I'm creating the right cube. Wait a minute. Wait a minute. It's been a while since I've used that create cube method. I wanna review that. Let's see. Create cube. Create cube. Okay. Yeah. So we get our vertices, indices, create our buffers and all of that stuff. We don't have any of that, yet we're storing it. We're just not taking in any of it. But maybe that's causing problems. I mean, it might be that we have to incorporate these regardless. Which would be kind of strange. I don't think that's the issue, but it could. No, it's not. Did you use the correct program? What do you mean? Elaborate. Oh, shader program. Oh my gosh, you're right. Yes. I should have. I believe I did. Draw debug cube. Draw the debug cube, draw debug shader, and then just to make sure, begin draw mesh. Yeah, it uses whatever program we give it. Mesh VAO. That's correct. We do use these. We don't use these, but uploading uniforms to things that don't exist shouldn't cause any problems. And then end draw mesh, draw elements, mesh.index count. Maybe our index count is wrong. Somewhere here. Do I have RenderDoc installed? I recently got a little bit of some upgrades on my PC, so I may not have RenderDoc installed yet. We shouldn't need RenderDoc for this, though. I mean, that would be kind of stupid. Break out RenderDoc for like a cube that we can't see. We're using transform. You know what? Let's just see this. This will show us if it's our shader. No, we actually aren't getting the cube. Okay, so it's not an issue with our shader. We are having a problem with the actual cube being drawn. Maybe. Oh, I'm stupid. Oh, I'm so stupid. We don't have debug mode on. I believe, you know what, screw this. We're just gonna draw it regardless. Let's see. Yep, there it is. We literally did not have debug mode on. I'm sorry, y'all. That was bad. There is no excuse for that. Make this cube a little bigger. And then I would like this to be a wireframe. Look at that. Debug cube. All right. How do we do? We could do GL, like draw lines. We could just turn it to using that mode. Actually, would that be a bad idea? No, because then we'll see the triangle faces. That's the other problem. We would be, okay. I'm gonna have to write another custom freaking method for this stuff. Yeah, create cube. The problem here is that if we did like draw lines, you would see the fact that there's just a bunch of triangles making up this cube, which I've done before in engines. Like it's not a horrible thing to do, but it feels a little bit. Actually, here's an idea. Maybe we don't do wireframe based debugs. Bold right there. Maybe we do something that's like, how could we make this cool? How could we make some sort of like cool debug visualization that's not normal? Okay, let's see. Debug visualization shaders. Let's find some inspiration for this. Debug cube shaders. If any of y'all have ideas, this is your chance. Wow, we've gotten 101 views on this. This is actually very cool. I'm very happy about this, I gotta say. I've never had this many views on a stream before, but it's pretty neat. Debug debug. What would the term be? I'll pull this up for you guys too. Debug visualization shaders. Debug what? Maybe we have some sort of like transparency is rough. I don't want this to be transparent. Maybe the best. Maybe there's a way we can just see like edge shader GLSL. Draw edges of a polygon in OpenGL shaders. That seems like what we want. Visualization, edge enhancement, wireframe tutorial. We could do that. Sobel edge detection filter. Maybe edge shader using OpenGL ES. I don't know if that's exactly what we want. You know what? Maybe for now, we will just take the easy way out. We can improve this later. I don't want you guys to, this stream to just become me Googling. That sounds boring for even me. I'm used to sitting in a chair for hours writing code. Let's see. Yeah, maybe in this debug, we'll just say GL, what is it? What was it? Enable wireframe mode in OpenGL. What was it? There was a single line command. Yeah, GL polygon mode. Polygon mode. GL front and back. GL line. And then what's the, yeah, we'll just set it back to fill when we're done. GL fill. And this should, GL polygon mode for now, I guess. Yeah, that's what I'm thinking. Let's see, GL poly. What did I do wrong here? GL line was not declared. Maybe it's GL lines, I think. I don't remember it being GL line. GL polygon mode was not declared. Uh-oh. Is this not something in OpenGL function with GL line? GL polygon mode, unless I'm a dumbass and I'm spelling things wrong. I don't think that's the case. Maybe it's like GL fill mode. OpenGL wireframe fill mode. Let's see, what was it? Okay, this is definitely not it. I mean, what was the command for this? This is like a one-liner. This should be easy. Stack Overflow. GL polygon mode, GL front, GL line. We'll just do GL front, GL line. This shouldn't. Front GL fill. This shouldn't cause any problems. I don't know what on earth is going on. Where did he get this from? GL line was not declared. GL lines. Could this be the fact that we're using OpenGL ES? Because I'm 99% sure that this was a thing in OpenGL. GL polygon mode is not declared in the scope. Did you mean GL polygon offset? No, I meant GL polygon mode. Let's see. Draw lines in OpenGL ES. What is the easiest way to draw lines? No, we're not using their immediate mode graphics. That is too old for even me. Draw line primlet. We could do that. Could say GL lines. I don't think that's how I want to do this, but let's just begin draw mesh. We're not using this method anywhere else, so if we just did GL lines, that should just have us draw this with wireframe mode. Yep. Well, that ain't right. GL... What's GL triangles? GL lines. Let's see. What were the different modes? OpenGL draw modes. I'd like to know what all of these are. Let's see. Draw modes. Mode. What's the... GL draw arrays. Maybe we use GL draw arrays. GL draw lines, GL draw arrays, and then we'll just do vertex count. That should work. This is, I mean, slightly slower, but then again, OpenGL ES isn't known for being the fastest in the game. Static graphics from GL draw mesh and what? GL draw arrays, right? Oh, it's a completely different method. What was it? GL draw elements. GL draw elements, GL draw arrays. Triangle strip 0. Yeah, it was 0. And then remove that. Maybe this will get this to work. It's weird on GL underscore line. Yeah. It definitely. What? That ain't it. Man, there's got to be like a list of all the different draw modes. Oh, there's an images. Oh, that's perfect. GL points, GL lines, GL line strip. Maybe it's GL line strip. Although we're definitely going to have those ugly triangles. Let's see, GL line strip. Uh-oh. I got some sort of stream notification. I don't care about that. What's going on here? Warning, stream's current bit. Oh, it's the stream bit rate. We're all right. I thought there was something serious going on. Let's see. That's better. That's still wrong. That's still disgusting, actually. But GL line loop. This shouldn't be what's going on here. Let's see. GL triangles works like that. GL line loop, GL polygon, GL quad, GL triangle strip, GL triangle fan. All right. I'm gonna not. My gut is telling me to consult Claude and reorder the vertices in a way where this would work. But I'd like to hold off on that. I always feel dirty after I use an AI for any sort of like code work. I just feel like I'm contributing to the problem. And I don't want to contribute to the problem. I would rather have code that doesn't work at all or spend forever debugging than add to the slop. That's my 2 cents. GL line loop. We'll try GL line loop. We'll see which of these works best. Worst case, we can do some sort of GL draw arrays. I don't know why the plane is deciding to go spaz mode. Let's see. That might be... I'd really rather not do that. I really would rather use polygon mode. This is a big deal. GL polygon mode not working in Emscripten. What is going on here? GL polygon mode is desktop OpenGL, not directly. They should have their... To get that working with Inscription, use the following instructions. Legacy Inscription, if applicable. Alternative GL enable GL polygon draw wireframe filled polygon assure C++ mode compatibility. Google Emscripten GL polygon mode. I've tried with BGFX. Okay, that's BGFX. I made a video on that had BGFX in it recently. You should check it out. That was a shameless plug. I'm sorry. We only have like 15 minutes left of the stream. But I think I can fix this before then. GL polygon mode isn't working. GL polygon offset. What? Front and back GL line. This should be. There's no polygon mode in OpenGL, but I don't know if it's that. I think it might be the fact that we're using Emscription. Look, this is what I signed up for when I decided I was gonna make a browser game in OpenGL ES. That's all I'm gonna say. But we could do this conditionally. If def Emscripten, and then we'll do this. Hashtag else. Hashtag end if. Worst case. Watching this video makes me think that I am a genius. You probably are a genius. Has no one ever told you that or something? Let's see. Okay, that doesn't work, but that's backwards. But this should work. I don't know why. I guess it is just OpenGL ES. That's unfortunate. There's got to be some sort of method to do so, but that's all right. All right. Well, OpenGL, ES, what was it? Not MSA. They don't have MSA. OpenGL ES draw lines. Is there any workaround here? Yeah, OpenGL GL lines. Yeah, you have to do it manually in that. Okay, maybe there's a line shader. OpenGL line shader. Maybe try using shaders. Yeah, that's what I'm thinking. Draw a line in modern shaders. Using standard GL triangle. I don't want to do it through that. This is not okay. There has to be, because I don't think there's geopolygon mode. Yeah, I'm starting to think that too. Unfortunately. I mean, hey, at least we got from here. It should be easy to fix at this point. Like this would just be like we have our debug drawing working. It's just a matter of now getting it to look the way we want, which is not hard. Okay. Last thing I want to do is, you know what? Heck. That's all we need. And then t dot scale equals glm vectory 10.0. And then, are you kidding me? I'll be honest, I don't know what the heck happened there. I guess that. I guess that's something. Yeah, there we go. All right, you got that. We could also have circles and spheres and all that. I mean, from there, it's just generate a different mesh based on what we need. Spheres we could do just using a shader, like just a check if the point is within a certain radius. That would look nicer, honestly. But, I think, well, I think that might be a good stopping point, honestly. We got this working now. Of course, it's not working properly, but we have the basic movements and controls working. From there, make it work first, make it good later. We're going to make it work. It's already kind of working. And then we have our debug mode here too, which I will fix that. Yeah, that should honestly be it. Let's push that to the GitHub repository. Let's see. Basic control surfaces and debug drawing. Commit, push. Let's see and make sure the GitHub is all correct. I need to add, at this point, if I'm live streaming this project, I kind of have to add a README. You know what? We have like a couple more minutes. Why not? We'll add a README. Yeah, you're in restricted mode. I don't even know what that means. All right. If I'm in restricted mode. And for now, we're just going to use a previous README and then just kind of alter it. Let's see. Yeah, this looks like a good README to use. Go here. Working title. Fox2.io. A web game centered around dog fighting and around multiplayer dog fighting. And details using OpenGL ES. Desktop version currently in development, in parallel development. This is actually in development, not a finished project. It's currently, yeah, they'll keep that. Screenshots. For now, we will not have any screenshots, but we will add them. Lessons learned. We haven't learned any lessons just yet. We're still making the same mistakes. Building from source. Okay, I can get y'all to build this from source. Let me see what's in this repository. Because if all of the if all of the files are in the right place, all of the like extra stuff, you should be able to build this from source. Let's see. Vendor. Do I have all this stuff? That looks about right. GLFW. Uh-oh. I remember. Some of these are stop tracking and git ignore. Okay. Building from source. We won't have that just yet either. I need to add those back. Commit directly to master, fox2.io. Oh, one more thing. Tune into the live streams to watch development. And then live stream. Let's see. Channel link. And then we'll add my YouTube channel link in here. Because why not? View your channel, copy, paste. Commit changes, done. All right. Oh, that's hideous. I'm sorry. I can't just have that there. There. Commit changes. There we go. All right. That should be it for now. Well, thank y'all for tuning in. This was definitely eventful. Please let me know if y'all were entertained. I know, admittedly, development is slower when you live stream it. I get a lot more done when I'm not chatting. I will admit. So if you feel like we didn't get a lot done today, me too. But it was worth live streaming. I said I was going to live stream this. I plan on still live streaming this, and I hope to get better at this. I mean, there are people who developed entire games on live streams. If they can do it, I can do it. So, yeah. That's all we've got so far. But, yeah. Thanks for tuning in. Maybe I'll make this Trello board public. Maybe there's a way I can do that. And if I do, I will put it in the description of this live stream. You should be able to just keep track of where we are with everything. We're almost done with debug visuals, in progress flight controls. That works. All right, guys. Well, this was fun. I will see y'all later. Thanks for tuning in. Just joined lol. Oh, sorry, bro. Hey, you can watch the recording.